Tech giants and governments are pouring billions into a strange new kind of machine, kept colder than deep space and capable, in theory, of solving problems that would take a normal computer longer than the age of the universe. They're called quantum computers. But what actually makes them so different from the laptop on your desk? Let's break it down.
Start with the computer you already use. Every phone and laptop stores information as bits, tiny switches that are either 0 or 1. Everything you've ever seen on a screen, every video, every game, is ultimately just billions of these zeros and ones flipping incredibly fast. It's simple, reliable, and astonishingly powerful. But it has limits. Quantum computers throw out that basic rule. Instead of bits, they use qubits. And thanks to the bizarre laws of quantum physics, a qubit doesn't have to be just 0 or 1. It can be in a blend of both at the same time, a state called superposition. Picture a spinning coin, not heads or tails, but a mix of both while it spins. Here's why that's powerful. 2 normal bits can only be in one of 4 combinations at a time, but 2 qubits in superposition can represent all 4 at once. Add more qubits and the possibilities double with each one. A few hundred qubits could hold more combinations than there are atoms in the entire universe.
There's a second piece of quantum magic: entanglement. When qubits become entangled, they're linked, so the state of one instantly depends on another, no matter the distance. This lets a quantum computer explore a vast web of possibilities together, in coordination, rather than checking each option one by one like a normal machine.
But qubits are incredibly fragile. The slightest heat, vibration, or stray particle can collapse their delicate quantum state, an error called decoherence. That's why those golden chandelier machines exist. They're elaborate refrigerators, chilling the chip to near absolute zero, colder than outer space, to keep the qubits stable just long enough to compute.
So are quantum computers just faster PCs? Not at all. For everyday tasks, email, video, browsing, they're actually worse and far more finicky. Their power is narrow but profound. Certain special problems where you must search a staggering number of possibilities at once. For those, a quantum machine could find in minutes what would stump every supercomputer on Earth.
What kinds of problems? Designing new medicines and materials by simulating molecules atom by atom, optimizing giant systems like traffic or shipping, and cracking some of the encryption that secures the internet today, which is exactly why the race to build them and to build quantum-proof security is so intense.
We're still early. Today's quantum computers are noisy, error-prone, and have only a modest number of stable qubits. Building a truly large, reliable one is one of the hardest engineering challenges humanity has ever attempted. But progress is fast, and the potential payoff, simulating nature itself, is enormous.
So a quantum computer isn't a faster version of what you own. It's a fundamentally different machine that computes using the deepest rules of reality itself, harnessing superposition and entanglement to glimpse answers hidden from ordinary computers. And if there's a science or tech topic you want explained next, tell me in the comments. Your question could be the next video. If this made you a little more curious about the world, subscribe to the Binary Brew, and I'll see you in the next one.